One of the most important parts of a security process or security framework is really taking into account that, every system is different, every deployment is different. And so the risk management framework does account for that in the first two steps. And the first two steps are categorize the system and select security controls. And as a security engineer by trade and at heart, this was a process I was very involved with several times when I worked supporting the National Security Agency. So, depending on what kind of deployment we were doing, what kind of data was going to be there, what kind of what people had access to the system, and where it was going to live, that dictated what controls were selected to apply to that system, because it's not cookie cutter. We know that every security control doesn't apply to every system. And so being able to select those controls and kind of tailor it is really the word that we use. Tailoring a profile to a specific deployment is a really, really important part of the process. So then we end up with a list of applicable security controls that we need to meet. And part of those security controls are going to include a technical side, right? The technical implementation of those controls in the actual system. So we obviously want to do the selecting of these controls before building the system. I think that is key, right? We're talking about kind of shifting security all the way left here. So before we've even started engineering work, we're figuring out what controls are going to apply. So once we have the controls, the next step is for the engineers to apply those controls essentially to building the system. So Kendall, you were on the other side of things. So you were the one that got handed, maybe this list of security controls, which in some cases could be pretty broad, but you're basically given a spreadsheet with a bunch of security controls on them and told, implement these on the system so that we can get through ATO, right?
Yeah, I think that's exactly how it started, is a list of security controls that were from the NIST 853 framework, and they would say things like implement a password policy, and they would say things like audit your systems, or just high level stuff like that. And so you would think, okay, well, how hard could that possibly be, right? Well, it turns out the answer is very hard, because there is not something that really translates those policies into specific rules on a system where everyone can agree on exactly, yes, this is what we do or don't need here. So a lot of times, if you want to try and correlate or facilitate, security controls on a system, you're reliant on something like a STIG, a Secure Technical Implementation Guide. So DISA, the organization, produces those. And really what they are benchmarks that you can use to scan a system. The trouble is, one, they are biased. They are a version of an implementation. They are not necessarily the only one, and they're not necessarily always correct. So when you're using these for validation, you find false positives, you find false negatives. You don't necessarily have the ability to account for exceptions. I like to think that there's probably no program that's 100% compliant to any existing framework. So there's always some concept of exceptions in there. So what it was like kind of, 15 years ago when we started doing this was basically exactly what you said. We would get a spreadsheet and it would say, we need to get through ATO. In order to get through ATO, go do this. And it'd always be, from our side, what do you actually want, right? What are you going to use to validate that I've done this? Because I don't want to do this work multiple times. So can you actually tell me the thing that you want? The answer is usually no, or just scan it or something. If we're really lucky, we might get a benchmark that we know ahead of time. But I think that kind of sums up just this conversation, why there are inefficiencies, right? Like, we are two people working to do this for one system, and we still don't exactly know if we're talking about the same thing. So I think, living on the engineering side, the issue was, it wasn't engineering talent. It was that there wasn't really enough background on the security and policy side to even understand what the objective was.
Right. So we give you the spreadsheet, we tell you implement this stuff, and then you're like, okay, I'm going to do my best to adhere to what they're telling me to do. So I'm going to implement some things, maybe run a few scripts that you've written to try to harden the system, find some technical implementation guides. And then it gets handed back over to me, and I take a tool and I scan it to make sure that you did what you were supposed to do. And now we have a lot of findings because you may not have implemented it exactly how the scanner wanted you to implement it. And then I take those findings and I toss them back over to you and I say, fix this. And you're like, where do
Yeah.
I even
So
start? Like, what do you actually want?
yeah, this is a real story, right? This really happened and continues to happen on defense contracts or defense programs. And I think we've arrived at kind of one of the funny ways to look at it, because the first time this happened to me, my genuine reaction was, why is this a spreadsheet? Right? And to that point, this is again when I say that we have different backgrounds, and even though we're working to solve the same problem, we don't always speak the same language. So if I could offer one piece of advice to the DoD, spreadsheets are not first-class engineering artifacts. We don't like dealing with them. They're not the easiest thing to parse. We don't read them like humans. We make computers and robots do this stuff for us. So like, I just think we could do better than spreadsheets. And that is, again, so I would get these, I think they usually came from like Nessus or something, but regardless, whatever scanner it was, we would get these reports and it would just say we failed. And so the question then is, do I go through the effort of manually documenting the reason why the scanner's wrong? Like, is it worth proving that just because the scanner didn't get a 14 character length password, it got an 18 character length one? Like, that's still compliant. I don't have to fail that. So you kind of run into these issues, right? So yes, I would say that you described it perfectly. We would get these spreadsheets. First, we'd have to figure out, is it a false positive? Is it a false negative? Should there have been a documented exception? And do I either want to reconfigure this thing to make the scanner pass, or do I want to create a bunch of documentation to give to you to verify that, yes, I'm still as compliant as I said? So again, just lack of consistency, lack of artifacts that we can use, lack of shared knowledge, I think.
Yeah, and I think, when you and I were working together on this stuff, we at least had, we had pretty good communication, I think. But in a lot of organizations, there's not necessarily like a relationship and a lot of communication between these teams. It's an email with an Excel spreadsheet attachment, and your context is, fix this, and it goes back and forth. And so ultimately, what ends up happening is a lot of frustration, I think, on both sides. Like, why can't you just do this for me? This is what I need. It's a requirement. And you guys being like, why can't you just actually tell me what I need? Right? What are the requirements? What is the actual implementation you want to see here? And so there's a lot of frustration. But really, like, I think the biggest issue is that this back and forth adds so much time to the process, right? And anybody that's been through, an accreditation process knows it can be lengthy anyway, and that's when everything goes perfectly. And now you're adding weeks and months of back and forth between an engineering team and a security team, because they're just not speaking the same language and they're not on the same page, even though they're trying to achieve the same goal. So obviously this was a huge problem for us, and so the technology for Sicura was created specifically to address this problem, kind of this lack of communication, this lack of the engineers really having what they need to be able to do their jobs appropriately, because we can't expect engineers to be, right, security control experts. And security engineers don't necessarily know exactly what needs to happen on the implementation side either. So I'd love to hear, honestly, like, you talk a little bit about, how Sicura solves that problem from an engineer's perspective.
Yeah, definitely. Really quick before I get into the how, just to touch on the why, which you hinted at. Why I, as an engineer on a defense contract, or wanted to solve this problem, is because I just could see a tremendous waste of talented engineers needing to solve bureaucratic problems instead of meaningful ones. So I have said multiple times in my life, and it will continue to say until I think this problem is solved, I want engineers to solve meaningful problems. And so that is why we built Sicura, is to try and help facilitate that. So the how is really interesting. So what we do is we source from a bunch of open source and proprietary data sets. Just to mention a few, I already mentioned DISA. We use benchmarks published by DISA. We also partner with a group or an organization called CIS, and we use security controls and benchmarks from there. Obviously, we use security control information from the different NIST frameworks like 853 and 800-171. So what we do is we take all of this data and we build mappings into specifically things that you can both configure and you can scan against. So what Sicura ultimately aims to do is build a security profile that is useful to both security professionals and engineering professionals. So on the security organization side, Sicura allows you to build a security program based on security controls from some framework like NIST 853 or from CIS or something similar. Decide, is this for an ATO? Is this for CMMC? Is this for maybe a commercial framework like PCI DSS? But basically be able to generate a list of controls that you want to make sure are enforced throughout your IT organization. And what you get on the IT side is those security controls turned into artifacts that you can use for scanning, that you can use for enforcement. So an artifact is a generic term, but a profile comes with a list of controls. It comes with benchmarks for all of those controls, and it comes with pieces of configuration that you can actually enforce. So from those controls, we can build a system, we can harden it, we can monitor and scan it, we can do remediation for entire profiles, for individual security controls, or even individual rules that make up those security controls. So what Sicura is a translation engine from policy directly into something that you can, again, build infrastructure from.